On day, yeah, in day one, we have discussed about the roadmap. Okay, what are the things I'm going to cover in this course? Okay, and then what are the projects I'm going to share with you? Okay, we have discussed these points. Okay, so and then I have clearly highlighted that we are going to do two projects. Okay, we are going to do two projects. One with the complete Snowflake core concept by using Snowflake objects like stages, task, storage integration. Another one by using completely the third-party tools like Fivetron, Metri, and DBT and Airflow. So these are the two projects we are going to do in this course. Okay, so yeah. Okay, so then we have discussed about the course content. Okay, so what are the things you need to learn in this course? Okay, so that's it about the roadmap. In the second class, I have explained about the software layers. So what are the layers we have in the Snowflake or in the IT industry? Okay, so we have three layers. Okay, one is on-premises, another one is PaaS. Okay, third one is IaaS, and the last one is SaaS. Okay, so we have discussed about servers, okay, and why we are not using the on-premises method, why we have chosen the cloud method. All those things we have discussed in the last class. Okay, if you have missed this class, just go with the recording. Okay, so today we are going to discuss about the Snowflake. Okay, the difference between Snowflake and the traditional databases and the Snowflake architecture. These are the things we are going to learn today. Okay. So yeah, let me start today's class. Okay, if someone asks me, how you can define the snowflake? How you can define the snowflake? I can define the snowflake in simple terms. Okay, in simple terms. Okay, what exactly mean by snowflake? If someone asks what exactly mean by snowflake, can you explain in three simple terms? I can say snowflake is cloud native, data platform, and completely SaaS method. So in simple terms, if I want to define Snowflake, Snowflake is a cloud native data platform and SaaS model. Okay. Eh, Okay, so how we can understand this? Okay, I'll give some simple example. Okay, we'll take one on-premises database. Okay, assume this is a Oracle. Assume this is a Oracle database. Okay, so I have installed Oracle in a server having 16 GB RAM, having 16 GB RAM, okay, 500 GB SSD. Okay, in the other hand, we have a Snowflake. In the other hand, we have a Snowflake. So where this Snowflake was hosted? It was hosted completely in the cloud environment. So we cannot install Snowflake anywhere in the server. It is completely cloud native, which means while registering in the Snowflake, you will choose one of the cloud. Okay. Now, whatever the data you are inciting into this application, okay, what are the queries you are processing with the help of VM? So everything will be provided by one of these cloud provider, either AWS, Azure, or GCP. So Snowflake is completely depending on one of these cloud provider. That is the reason we called Snowflake as a cloud native application. Okay, second thing, I have created a database. Okay, I have created a database inside this Oracle. Okay, same as well as in the Snowflake. Okay, so here, whatever the data I'm storing, right, I'm using SQL here. Okay, whatever the data I'm storing, I'm using SQL here. Same will be applicable in the Snowflake itself. So I want to process some data or I want to insert, retrieve or anything, everything will be SQL based. So this Snowflake having characteristics like all your data, all your user. What exactly mean by all your data? Snowflake will support structured, unstructured, semi-structured data. You can store both structured, unstructured, and semi-structured data in the Snowflake. Okay, that is the first point. Okay, so next one. Okay, let me go with the slide. Next point. So what is structured, what is semi-structured, what is unstructured data? Structured data means the data which is in a readable format, that we call it as structured data, like names, email IDs, mobile number, phone number, all those things we call it as a structured data. What is semi-structured data? If I am storing multiple values in a single cell in the form of key value pair, then I call it as a semi-structured data. What is unstructured data? Images, documents, videos, all these things we call it as a unstructured data. Now to store structured, semi-structured or unstructured data. Okay. Unstructured data means, semi-structured data means it may be a JSON file, XML file, Avro file. Okay. We use Snowflake. Okay. Snowflake will support all the three. Okay, and it has centralized data repository, so which can be accessed by the authorized users. So the person who are having the access related to that particular object, they can access this database, and it is designed to operate effectively on multi-petabyte scale for massive data volume. This is completely designed for huge volume processing. Okay, I'll go with again example here. Okay, assume I'm loading some file. Okay, I'm loading some file into both the databases. Assume this is 1 GB file. Okay, and there is a one more file. This is 1 TB file. Okay, every day I'm receiving this file, 1 TB file, and sorry, I maximum capacity is 500 GB, right? Fine. Let me go with this example. I'm loading this file every day. Okay, within a 500 days, this server is completely filled. This server is completely filled, which means you cannot insert any more data into this database. Why? Because I have loaded this file daily for 500 days. That's it. This server is full. Now what I need to do? Okay. Again, I need to purchase a new server like 1 TB or 2 TB or 5 TB. I need to do the migration from here to here. And this is a costly process where multiple teams are involved. Okay. So I need to purchase some space for racks, new servers and all those things. It's a costly process. Okay. And every time the business will get impacted here. Okay. In the other hand, what is the storage capacity of this cloud storage? It's infinity. It's infinity. You can store infinity volume of data inside the Snowflake, which means we have here in the Snowflake, we don't have any storage issues. Okay. So we can store huge volume of data. Snowflake is completely designed for storing huge volume of data. Okay, so this Snowflake is completely designed for storing huge volume of data. Okay, in the second one, all your user. What exactly mean by all your user? So multiple group of users can access Snowflake simultaneously without compromising the performance. Okay, so in the Oracle, in the Oracle, assume multiple teams are accessing this database. Okay, assume multiple teams or multiple people are accessing this database simultaneously. Okay, so okay, how this will be given? Okay, so it will give response one after the other. Okay, this will give response one after the other. So first user one will get the result, then user two, then user three. So user three need to wait for 2 minutes, like 1 minute for this guy, 1 minute this guy, and then only he's going to get the result. In the other hand, in the Snowflake, multiple people are going to get the result. Why? Here, computing, resource, everything was differentiated. Okay, all these three was differentiated. So multiple people will get the result simultaneously. No need to wait for the other people getting the result. Here, everyone will get the result simultaneously. In the other hand, in the Oracle, so this user three need to wait until he get the result for 1 and 2, then only he's going to get the third one. అంటే మనకి ఒరాకిల్ ఎలా ఉంటుందంటే ఒకేసారి రిజల్ట్స్ ఉండవు, ఇక్కడ మనకి థ్రెడ్స్ అనే ఫామ్ అవుతాయి. ఓకే, యూజర్ 1కి రిజల్ట్ వచ్చిన తర్వాత యూజర్ 2కి ఇస్తుంది, యూజర్ 2కి వచ్చిన తర్వాత యూజర్ 3కి రిజల్ట్ ఇస్తుంది. అదే స్నోఫ్లేక్ ఏంటంటే సైమల్టేనియస్ గా ఒక్కొక్క యూజర్ కి రిజల్ట్ అనేది షేర్ అవుతుంది. ఓకే, సో దట్ ఈస్ ద డిఫరెన్స్ బిట్వీన్ ద ట్రెడిషనల్ డేటాబేసెస్ అండ్ ద స్నోఫ్లేక్. Okay, coming back. So capable of supporting unlimited number of users at the same time. Okay, so there is no queue in the Snowflake. So an unlimited users can access the Snowflake at a time. Okay, automatically scales resource up or down based on the demand. Okay, what exactly mean by this? I'll show with the example. Same thing. Okay, I want to load 1 TB file. Okay, what is the compute capacity of this Oracle? 16 GB RAM. So to process this file, okay, to process this file with this 16 GB RAM, for me it is taking 1 hour. For me it is taking 1 hour. Why? Because I have very less computing server. Okay, 16 GB RAM is very less computing when it comes to 1 TB file. Okay, now to process this 1 GB, I don't need to use this 16 GB. 4 GB RAM is enough for processing this file. Even though I need 4 GB RAM, I'm putting here 16 GB RAM. అంటే నాకు ఇక్కడ ఏమవుతుంది, అవసరమైనప్పుడు పెద్ద ఫైల్స్కి ఏమో ఈ 16 GB RAM సరిపోవట్లా. 4 GB కావాల్సిన చోట ఏంటి, నేను 60 GB RAM ఉన్న సర్వర్ని యూజ్ చేస్తున్నా.
Sir, can you please speak in English? Sir? We cannot understand.
Yeah, I'm repeating again. Okay, so I'm showing everything in this slide and I'm explaining everything in the paint. Okay, so here what I'm explaining, capable of supporting unlimited number of users at the same time. This I already explained. Automatically scale resource up or down based on the demand. Okay, so here I'm comparing Snowflake with the traditional database. Okay, so in the Oracle was installed in the on-premises server having 16 GB RAM and 500 GB SSD. Okay, so here what I'm telling, to process 1 GB file, I don't require 16 GB RAM. I require just 4 GB RAM. Okay, to process this 1 TB file, I need a 128 GB RAM. Okay, so but here I cannot make up and down. Okay, so everything will be processed within the 16 GB RAM. So if I'm processing 1 TB file with 16 GB RAM, it takes 1 hour, which will impact the business. In the other hand, for the same example, so if I'm processing 2 files, okay, one is 1 TB, and another one is 1 GB, 1 GB file. Okay, I can allocate 4 GB RAM server for loading the data into database. For 1 TB file, I can allocate 120 GB RAM, 120 GB VM for processing this file. So this 1 TB file will be processed within a 10 minutes or within a 5 minutes. Why? I'm using a large VMs for processing this file. Like that, I can make up and down the VMs. Clear? Any doubts up to here? So again, I'm repeating. So I'm trying to explain about Snowflake. Okay, what exactly mean by Snowflake? In a simple definition, Snowflake is cloud native data platform and SaaS product. What exactly mean by cloud native? Snowflake is hosted on one of these cloud platform. While registering in the Snowflake, you are going to choose one of the cloud platform. So whatever the data you are storing in the database or whatever the data you are using for processing the data, okay, or for processing the data, so that will be provided by one of these cloud provider. That is the meaning of cloud native. Okay, so this Snowflake is completely hosted on the one of these cloud provider. Okay, that you are going to choose while registering the Snowflake account. So that is the first point. What is the second point I'm explaining? So Snowflake is a data platform. What exactly mean by data platform? Okay, so in this Snowflake, okay, what are the operations you need to do that can be done by using SQL. Okay, and the second point is Snowflake is about all your data, all your users. What exactly mean by all your data? Snowflake is designed for handling peta volume of data, which means huge volume of data. Why? Because the storage capacity of this cloud provider is infinity. You can store infinity volume of data in this cloud platform. So that is the reason in the Snowflake also you can store infinity volume of data. This Snowflake will support both structured, semi-structured, unstructured data. So that is the second point. Okay. Then all your users. What exactly mean by all your user? If you take the Oracle as example, okay, so if three people has executed a query, okay, what Oracle will do, it will form the queue. It will form the queue. Queue means, so it will give result one by one, okay. So once user one will get the result, then only user two is going to get the result. Once user two got the result, then only he's going, Oracle is going to provide the result for user three. So user 3 need to wait until user 1 and user 2 got the result. Okay, it's like it will form a queue. Okay, Oracle will give result one by one. Getting it right? So if each user will execute a query, so if user 3 need a result, he need to wait until 1 and 2 complete it. In the other hand, multiple people can connect simultaneously and get the result within a seconds. No need of to wait until it doesn't depend on the result of other user. So any user can connect with any time and they can get the result accordingly. So any doubts up to here? Okay. And the last point, what I'm saying, assume there are two files. One is 1 TB, another one is 1 GB. To process this 1 GB file into the database, see here I have 1 GB volume of data. If I want to load this 1 GB data into the database, so I just need a 4 GB RAM. But here, as I'm using Oracle in on-premises environment, so entire 16 GB will be used here. Okay, so to process this 1 TB file, I need 128 GB RAM. Okay, but as I'm using on-premises server, this 16 GB RAM will be allocated. Due to that, what is happening here? So to process this 1 TB file, it is taking 1 hour to complete the process. In the meanwhile, business will get impacted because I need to order something. Okay, what I need to order is complete information is there in this file. So my business will start 9, but this file is taking to load into my database 11 o'clock afternoon. Okay, which will impact my business. So that is the reason this in the Snowflake, based on your size of your file or size of your operation, dedicated VM will be allocated. Now, if you want to process this file, you can you can dedicate 4 GB RAM, 4 GB RAM VM. Okay, to process this file within a minutes, what you will do, you will allocate 120 GB, 128 GB RAM for processing this file. So you can make or you can change the configurations anytime based on your requirement. Where? In the Snowflake. So that is about the data platform. Any doubts up to here? So if you have any doubts, you can ask me. Okay, fine. And the final one is SaaS. Okay, so we'll take the Oracle as highlighted before. Within a 500 GB, 500 days, this complete storage will be filled. Again, what I need to do, I need to ask DBA team, Linux team, Unix team. I need to do some operations. Then I need to do the migration into this server, into the large server. Okay, and again, if there is any upgradation, patching activities are there, DBA team need to come into the picture. So
ఏమన్నా
they,
ఏమొద్దులే కానీ మామూలు అడగాలనా?
sorry. Okay, they need to make this DB down. Okay, again, they need to do some upgradation, the Oracle version upgradations, patching activities. Okay, it's a hectic process. Okay, it's a hectic process. It can't be done very simply. Okay, so we need to make database every time down. Okay, we need to do a lot of planning. Multiple resources are involved here. Okay, so again, I need to spend uh, like huge amount on this on premises. In the other hand, Snowflake is a SaaS model, which means everything will be taken care by Snowflake. Okay, you don't need to do any migrations, upgradations, or patching activity or anything. Everything will be taken care by Snowflake. You just build the application and you use the application there itself. You don't need to worry about the security part. Okay, you don't need to worry about the security part or the storage part or the version part or upgradation part. Anything you don't need to worry about it. You can just build your application and use it like a SaaS model. Okay, so that is the difference between the traditional database and the Snowflake. So any doubts you guys are having? Clear? If you have any doubts, you can ask me or I'll continue with the next topic. Okay, so let me take this Oracle database. Okay, so where we get the data into data warehouse in the real-time scenario, we get the data from multiple source systems. We get the data from files, we get the data from web applications through services like Kafka, like that, from the SFTP, like from the source systems. Who is going to load data from here to here? So we are going to use a ETL tool like Informatica, Metlian, Fivetron, like that, to load data from multiple source systems into the Oracle database or on-premises database. Okay. Okay. Again, here the problem is like I need to pay licensing. I need to pay licensing for the Oracle. Okay, here I need to purchase the license for the Oracle. Again, I need to purchase license for the ETL tool as well. Here I'm paying multiple times uh, for the licensing, right? In the other hand, if you take the Snowflake, let me make it small. Okay, in the other hand, so Snowflake having inbuilt objects. Okay, Snowflake is having inbuilt objects. By using this inbuilt object, okay, I can do ETL as well as storaging with a single part. Okay, that to pay as you go model. So whatever the space I'm using, I'm going to pay for that. Pay as you go. Okay, so in the Snowflake, whatever see, I'm using 1 TB storage, then I'm going to pay only for 1 TB. Okay, so for processing the data, it takes 5 minutes. So I'm going to pay for that 5 minutes. So when in the other applications, I need to use multiple applications for connecting and processing the data into Oracle database. In the Snowflake, so Snowflake will support both storage as well as processing. Snowflake is having inbuilt objects. By using those inbuilt objects, I can connect with multiple source system. I can extract and load it into the Snowflake. Okay, so that is the difference between the traditional and the Snowflake. So if you see here in the traditional database, I need to use ETL tool for connecting with multiple source systems. In the other hand, in the Snowflake is having inbuilt object like storage integration like that. By using that inbuilt objects, I can connect with any source system. I can extract the data and I can load it into the Snowflake. Clear? Any doubt? Any doubt? Up to here. So yeah, I have given some example here. You can see here. Let me paste it. Okay. So if you see here, I have a files in the AWS S3 bucket. Okay. Now what I'm doing by using this Snowflake storage integration object, I'm going to load the files from S3 to Snowflake directly without using any ETL tool, any third-party tool. By using Snowflake internal objects, by using Snowflake objects, I'm going to connect with this S3 bucket. I'm going to extract the data from there and I'm going to load it into my Snowflake environment. Here I don't require any third-party tool. Everything done through SQL. Very simple, right? Okay, it's very simple, right? If I'm using SQL, it's easy for me to learn and understand. Okay, so by using SQL, we are going to do ETL things as well. That's the beauty of Snowflake. Okay, fine. I think you are able to understand what I'm explaining. If you have any doubts, you can ask me. If not, I'll continue. Okay, coming to here, let me go. So as highlighted, what is the Snowflake? It's a cloud native, okay, data platform, and it's a SaaS model. Okay, cloud native means this, whatever the data you are storing or processing, it will be from this cloud providers. Okay, next. That's it. That's it. That's it. Okay, so this Snowflake will support both batch processing, streaming data. What is batch processing? Okay, batch processing means assume I'm using some DMart. I'm using some DMart, right? Every day, so every day I'm getting data at midnight, 11 o'clock. After my business completed, closed, okay, the marketing team will upload the file into some AWS or directly into the Snowflake. So here what I'm doing by using some scheduler like Control M, by using scheduler like Control M or Airflow, I'm going to load data from here to here. Okay, so this is a scheduled activity. Every day, this activity will be executed at 11 o'clock. Okay, by 10, marketing team will upload the current sales. Okay, and these jobs will run at 11 o'clock and it will load data from this file to the database. This we call it as batch processing. This we call it as batch processing. Okay, in the other hand, okay, I need to generate the reports whenever changes happen. Okay, I want to see how the business is going on. Okay, so if I want to see how the business is going on, like I need to know current day sale, okay, past 3 hours sales, like that. So here I will not do batch processing. Here what I do real-time processing. How I can do real-time processing? Here I have two options. Okay, either I can use some third-party tool like Kafka for streaming the data. Okay, or I can use Snowflake inbuilt object called Snowpipe. This is Snowpipe, or you can use some third-party tool called Kafka. So what exactly these things will do? Okay, whenever files arrive in your S3 bucket or SFTP, whenever you have received the files in the source system, okay, this Kafka or Snowflake will detect this file and it will load the data within a minutes. Okay, this we call it as real-time real-time processing. Here we are not going to use any third-party tool. Okay, these guys, whenever changes happen in the source system, they will directly load the data from the source system to the destination. So this is batch processing, where we use some third-party tool and we schedule it. At that scheduled time, the data is going to load it into the destination. This is real-time processing. Okay, where whenever changes happen in the source system, that will be loaded into the database. So example for this real-time processing is like your cricket scoreboard. Okay, so when you are open any ClickBuzz, right, so whenever score changes happen in the source system side, that will be reflected in the mobile app. So what exactly they are using either Kafka or Snowpipe for instant results, that we call it as a real-time processing. Okay, batch processing means, see, I want to generate last 3 months report, 1 year report. Okay, how I'm getting the data? I'm getting the data after business closes. Okay, after business closes, the jobs will get executed and it will load data from source to the destination. This we call it as batch processing. This we call it as real-time processing. In the Snowflake, I can do both batch processing and streaming as well. Okay, whenever source system in the source system, whenever changes happen, so Snowpipe will detect that and it will load the data from here to the Snowflake environment. Clear? Any doubts? Any doubts you guys are having? Let me know. I'll try to figure it out. Okay, so yeah, as highlighted before, Snowflake is having its own marketplace, like our Play Store. Okay, in this marketplace, you can get the data. See, I want weather data or I want the pollution data. So there are open source data libraries are available here. Okay, open source data. Okay, by using this, you can import into your project. Okay, you can use this as the data. I mean, see, weather data. It's a public data, right? So those details are available in the Snowflake marketplace. Okay, so few are free, few are paid. Okay, few are free, few are paid. And if you want to sell your data, you have some customer details or you have some business related information. Okay, that you also you can sell in this marketplace. Okay, and now Snowflake, as highlighted before in the previous class, Snowflake now in the Snowflake itself, you can build a ML model. Okay, for building AI models, I use Cortex AI for doing the predictions. Okay, for doing this machine learning part, I have this Streamlit. Okay, so that is the reason this Snowflake is called Snowflake Cloud. Okay, if you search Snowflake, you can see they have renamed their product as Snowflake AI Data Cloud, which means in the Snowflake, you can build AI models as well. You can do the predictions for the data science. All those things you can do inside the Snowflake. You don't need to have any third-party VMs or third-party application to do this thing. Everything was inbuilt in the Snowflake itself. Okay. So yeah, that's it. That's it about the Snowflake. So I think you have some good understanding about the Snowflake. So in simple terms, if I want to define the Snowflake, Snowflake is a cloud-based data platform and SaaS model. Yeah, thanks guys. So that's it about the Snowflake introduction. If you have any doubts, you can ask me.
Sir, what is
So,
asset transaction?
sorry.
What is asset transaction?
So actually, for all the databases, okay, it will be too heavy for you. Okay. So if you guys can understand, if you are able to understand, it's good. If you are not able to understand, it's okay. In the upcoming class, I'm going to explain about these acid properties. Okay. Most of the RDBMS, most of the RDBMS will have acid properties. What is acid properties? A means atomicity, C means consistency, I means isolation, D means durability. Okay. So again, you need to have some knowledge on transaction, then only we can explain this proper acid property. How I can explain atomicity, consistency, isolation, and durability. Okay, so I'll go with one example. Okay, so assume you are doing some transaction in the ATM. Okay, so that ATM is not working. Okay, or there are some fake notes in your transaction. Okay, how the ATM will work? Either all your amount will be stored or will be credited, or your entire amount will be rejected, right? Okay. In the same way, if I'm doing transactions means multiple insert statements. Okay. If I'm multiple users are inserting the data, okay, or multiple users are inserting 100 records, right? Okay, either all the 100 records will get inserted or all the 100 records will be removed or rejected. Okay, partial transactions will not happen. So if I'm inserting 100 records, if there is any error in the transaction, either all the 100 records will get inserted. If there are no errors, 100 records will get inserted. If there is any error, so all the 100 records will get rejected. So even though the 50 records having no errors, that will not get inserted into the database. That we call it as atomicity. Okay, either transaction will get succeed or completely failed. Half of the records will not be done. Okay, second one is multiple users are doing multiple operation on a single table. Okay, multiple users are doing multiple a transaction on a table. Okay, this guy is inserting one record, this guy is updating the record. So this transaction will not conflict with each other. Okay, so and okay, here this guy is inserting 100 records, right? Okay, assume in the table I have 5,000 records. Until this transaction completed, this guys is able to see only 5,000 records. Once this transaction completed, then only he is going to see the 5,100 record. Okay, assume this transaction was started at 10 o'clock. It has taken 10 minutes. The transaction has completed at 10:10. So this guy, if he execute the select query until 10:10, he is able to see the 5,000 only. After the transaction completed, then only he can see that 100 records. So even though every minute 10 records are inserting, that 10 records will not be reflected to this user. So there will be a consistency. Okay, then the third one is isolation. So other queries will not conflict with each other. Okay, this guy is updating something, this guy is inserting something. So these queries will not conflict with each other. And the final one is durability. Once these records are committed, that will be saved permanently. Okay, this will not change when you are migrating the database from one place to another place like that. So these records, once it is committed, that will be permanent. It will not change if even though the database is down, if you have done migrations or upgradations, this will be permanent. So this we call it as asset properties. So who are having some database knowledge, they can easily understand this. So who are very new, don't worry. Okay, in the later class, I'm going to explain what is transaction. Okay, and what exactly mean by these asset properties. In the later class, I'm going to explain these asset properties.
Okay.
Okay, so yeah. Yeah, that's it. That's it about the introduction to Snowflake. If you are feeling heavy, I'll take a break here. So if you are okay, I'll continue with the Snowflake architecture.
Yeah, excuse me. One query here.
Please.
Yeah, so in the real-time processing of Snowflake, if we have the by default Snowpipe in the processing, why we needs to be use a third-party Kafka in between both of them?
Okay. So this Snowpipe have a latency of 1 minute.
Okay,
Okay. If you want instant result, if you don't want to wait that 1 minute as well. Okay. So Kafka will be the preferable one.
okay.
Yeah, and
So they
Kafka is a
one.
very old tool. Like it has inbuilt connectors. It come up with a lot of things. It support the Java and all those things. So when it comes to Snowpipe, it's completely SQL tuned.
Okay, okay, got it.
So these have limitations with the connection with multiple source system, but in the Kafka, you can use multiple.
Okay, yeah. Thank you. Understood.
Okay. So with Kafka have multiple connections inbuilt. When it comes to Snowpipe, so it has some limitations. It is
Okay,
completely SQL tuned, so you cannot connect with multiple source systems.
okay, got it. Thank you. Thanks for that.
So can I continue or shall we take a break here?
Yeah, I have one question. This is Koti. This is my first session. And
Okay.
so basically, I understood that. So this is this is a combination of traditional SQL as plus ETL tool. Am I correct? Snowflake mean.
Yes. Yes.
Okay. Yeah, thanks.
Okay. So can I take a break or can I continue? Okay, so okay, we'll take a break up to here. So this is about introduction to Snowflake. Okay, we'll share you the recorded videos in the group. Okay, you can go through it if you have missed something. Okay, thanks guys. Thanks on.